In this video, we're looking at something really practical which is used in many manufacturing companies and processes, and that's quality assurance and control charts. We're going to understand the process of it and why it's necessary, and we're going to look at things called warning limits and action limits and look at how those are used. So let's say you go down to your shop and you buy a packet of crisps. Now, if you look at the packet of crisps, it says that it weighs 50 grams. But in reality, not every single bag of crisps will weigh exactly 50 grams. This is what's called the target value. And that means manufacturers want the weight as close as possible to this. Now, there is bound to be some difference in the weights of crisps in a packet as a result of the manufacturing process. These changes are unavoidable. The weight of crisps in any packet might not be exactly 50 grams. However, the mean weight the packets produce should stay at 50 grams, and the difference between the minimum and the maximum weights should stay constant. So changes in the size or weight could be caused also by the wear of tools, very practical things like this. These changes could either cause the mean, the average weight to drop or to increase, to change, or it could cause the range of weights to change. If a change of this type occurs, the process is stopped. They have to reset the machines and recalibrate them. And quality assurance helps give us warning of this. It's to check quality. And what they do for this is they take samples regularly. And in a minute, we'll look at how to construct a chart to kind of visualize these samples in a really practical way. But let's just look at what taking a sample might look like. So let's say we've got this packet of crisps, and we take a sample of just 5 packets of crisps. We find the weight of these 5 packets and see if this weight is any good for us. So let's say if I weighed these packets of crisps, these are results I get. And I need to find the mean, the average of these results. So if I find the average of these results, I actually find it is exactly 50 grams. Okay, and usually we use the mean, but sometimes we'd use the median because it's often very quick. So if I was going to find the median, in this case it would be 50.1 grams, okay? But we usually use the mean. And so the mean of the sample would be 50 grams, which is in fact our target value. So although each individual packet of crisps is not at the target value, on average they are, so we're okay with that. And we'll look at that in a bit more detail in what's called a control chart. Quick note on the range. If I wanted the range here, I've got my largest and my smallest, so my range would be 1 gram of difference. Okay, and then I would take several samples and have a look at all the ranges of those. Okay, so we're now going to look at what is called a control chart. That's like a time series chart that's used for quality assurance. Now notice I'm actually looking at the sample number here, and I'm not finding the mean, and I'm finding the mean of each individual sample, so I'm not putting on each individual packet of crisps weight, but instead the average weight of those. So in the previous case, if we remind ourselves of the previous questions, I would not be putting on each of these numbers, but instead I would just put on the 50 grams because that is my mean of sample, that example sample. Okay, now let's look at the actual samples that we're given. So I have taken the sample means and plotted them on, and it looks a bit like a time series. Normally for time series we'd join them up and look a bit like a mountain range, but we're not doing that. We're doing a control chart. So for a control chart we're looking at how close they are to our target. So let's put on our target weight. So here we can see our target value, our mean, is 50. And now we're going to look at how close our values are to that mean. So we've got something called warning limits. And warning limits are set so that 95% of the means of the sample should lie between them. Mean sample mass is normally distributed so that 95% of values lie within 2 standard deviations of the mean. Just like normally when we have a normal distribution like this, if that was the mean and this is 2 standard deviations either side, we know that's 95% is in there. And so this time we're just going to have it, because we've got a chart like that, and this time that's our mean, we're going to have our 2 standard deviations so that 95% is like that, and these are called our warning limits. We will look at how to calculate these in a minute, but for now I'm just going to pop those warning limits on. So any data which is within these warning limits, so all of these numbers are considered okay, all these samples are okay, the process is said to be in control and the product is acceptable. But we have another limit called an action limit, and this is looking at 99.8% of the value, so of course that's 3 standard deviations, and 99.8% is basically almost all your data. So if anything is outside of that, then you know it's a real problem. So let's draw on our action limits. So let's have a look. We've already said that anything within the warning limits is fine, and we'd expect 95% of data to be here. Anything which is in between the action and the warning limit, so anything in here or in here, we're seeing, is there maybe a problem? Is this just a one-off, or is there an ongoing problem? And if it is between those values, we take another sample immediately. Okay, so another sample taken, and we see if it's within this bit, we're fine. If it's not, then we've got a problem. If, however, we've got something outside the action limits, remember that 99.8% is in here, so that's 99.8%, which means only 2 out of 1,000 should be here. So if there's an average of it there, there's a problem. So the process is stopped and the machinery is reset. Okay, let's have a look at an actual example looking at this in detail. So we're looking at a different manufacturing company, and this one is about pins. A machine produces pins with a target length of just over 5 centimetres, 5.04 centimetres, and samples of pins are taken and their lengths are measured. The mean length of the samples is 5.04 and the standard deviation is 0.02 centimetres. And we can assume it's normally distributed, which is important because we've been using that with our standard deviations. So between what lengths would you expect 95% of the pins to lie? Well, if you remember from our previous diagram, 95% is 2 standard deviations, plus or minus 2 standard deviations, which on a normal distribution would look like this. So we've got our mean is 5.04, our standard deviation is 0.02, so I'm going to add that on each time. So 5.06 and 5.08, and downwards 5.02 and 5.00. So between what lengths would you expect 95% to be? Well, 95% is up to 2 standard deviations, so you would expect that to be between 5.00 and 5.08. So it's the mean plus or minus 2 standard deviations. So that's 5.04 plus or minus 2 lots of 0.02. So that's 5.04 take away 0.04, which is 5. And also it is 5.04 plus 0.04, which is 5.08. So you'd expect it to be between 5 and 5.08. Likewise for 99.8%, that is the mean plus or minus 3 standard deviations. So this time it's 5.04 plus or minus 3 standard deviations. So you're going to have 4.98 to 5.10. Okay, let's have a look at our samples. Each sample has just 3 pins, and we need to find the mean of each sample. So in this case we're going to find it just by adding them and dividing by 3. So you can use your calculator, pause the video now and fill in your boxes. And likewise, your range is your largest value, take away your smallest value, so fill in those boxes as well. Take a moment to check that you have got the correct values for the means and the ranges. And then see if you can draw a control chart for the mean length, so we're just looking at mean, not the range, and even see if you can use your answers to part A as the warning and action limit. So if you feel like you can do that, pause the video and give it a go. If you're still completely unsure, then watch the next bit of the tutorial. Okay, so I've just plotted the mean values onto my grid. So if you haven't already plotted your mean values onto your graph, if you do that now. And the next thing is I'm going to have to draw on some lines. I'm going to have to draw on my target value and my action and warning limits as well. So my target value is 5.04 because that is the length that I've said they are, and it says the target length is 5.04. So I'm going to put a line on 5.04. Okay, so that's my target length. Now if I look at my answers to part A, then 95% values give me the answer to the warning limit. So my 95% values were 5 and 5.08. So that is my warning limits. I'm going to put those in. So there's my warning limits, and you can actually see really clearly in this graph that each of those is one standard deviation. So that's 2 standard deviations above and below, and that's my warning limits. And then my action limits will be another standard deviation each way, which once again the answer to part A tells me that it's the 99.8% values, and that's 4.98 and 5.1. And that is my control chart for my means with my warning limits and action limits. Okay, have a go yourself now using the range specifications there. The range has to be less than 0.3 centimetres with a warning limit at 0.25 centimetres. See if you can use that together with the ranges to draw a control chart. So first of all, you'll need to plot all the range values on, and then draw on the warning limits and action limits as given in the question. So here I have my ranges, and I'm just going to draw my action line at 0.3 centimetres and my warning limit at 0.25 centimetres. And it's important to note that there are no lower limits for the range in this case. Okay, no lower limits in this case. Okay, so all I've got to do now is to look at both my control charts and comment on any action that would be taken. So if I have a look at my range chart, everything is within the 95%. All of these are where they should be. They are below the warning limit. There is nothing in between, and there is nothing above. So no action would be taken in the range at all. No action needed for the range is in control. Let's have a look at the mean situation. Now the majority of our data is within the limits, okay, even within the warning limits. There is nothing in between action and warning above or below. However, I do have this piece of data here. My 4th sample is above the upper action limit. This means I would have to stop and reset the machine. And you can see when I've done that, we then go back within limits. Okay, so after that, we're looking good. So this, I had to stop and reset the machinery, and then it became back in control, back within my limits here. So let's write that down. So what we're looking at is using machines in factories and looking at when they need to be reset to make sure the quality of a product is consistent, remaining at the level which we're expecting it to be. And when it's not, the machinery has to be reset to make sure it then gets back within the relevant quality. Have a go at some practice questions now.